Hi there, so today we'll be focusing on these two bullet points of the AQA GCSE Maths specification. So if we look at the first one, it's expanding the products of two binomials. So binomials are two terms, like up here, that are added together or subtracted, and in this case we've got one unknown, which is x. So what we do when we're expanding these two out, let me just change the colour on this. So we look at the first x term and we times it by the second one, which is x squared, and then we times it by the second one here, which is plus 2, so that's plus 2x, and then we look at the second term here, which is plus 1, so we do plus 1 times x, which is plus x, and then we do plus 1 times by plus 2, which is plus 2. Perfect. So then we can simplify this down by adding the two x terms here. So that equals x squared plus 3x plus 2. And that's as simple as you can go with that, and that's the final expansion of multiplying these two binomials. So have you got any questions on that? Okay, perfect. So if you want to have a go at this and explain to me what you're doing whilst you're working through it. Okay, great. So the next part of the specification says factorizing quadratic expressions of the form x squared plus bx plus c. So if we focus on that for now, in this example here, I've got x squared plus 12x plus 35, so b in this case is 12 and c is plus 35. So what we want to do is look at 35 first of all and work out the multiples. So if you can tell me the multiples of 35. Yep, so 1 and 35 and 5 and 7. So once we've got these two multiples, we can see which combination of these can add together or subtract to make b, which is 12 here. So as you can see, you could do 5 plus 7 to give you 12, and that makes up the 12x. So what we then factorize that to is x squared plus 5x plus 7x plus 35. And now you can see that you can take out a common 5 out of the 35 and the 5x. So just remember as well, factorizing is the reverse of expanding. So we've started off with an equation like this. It will always end up with two brackets with the x unknown terms in them. So we write out our two brackets here. So as we've worked out, we've got plus 5 as a factor, so we can do x plus 5. And we've also got 7 as a factor that we can take out, so we put x plus 7. And those are the two brackets that factorizes to. Have you got any questions on that? Okay, great. So do you want to try question 4 that I've got for you here? And explain to me what you're doing as you're doing it. Okay, So last of all on the spec it says including the difference of two squares. So if we start off by expanding these two brackets, as you can see there's a plus 5 as one of the terms and a minus 5. So it's the same number, just a plus in front of one and a minus in front of the other. So if we expand it out, we do x times x, which is x squared. And then we can do x times minus 5, so that's minus 5x. And then plus 5 times x, so that's plus 5x. And then plus 5 times minus 5 gives us minus 25. So as you can see here, minus 5x and plus 5x actually equal 0 when you add them together. So they balance out, and it's x squared minus 25 as your final expansion. So what you need to recognise is any equation in the term with x squared minus a square number, so 4, 9, 16, all the way up to 100, will always factorise out to x plus the square root, x minus the square root. So after knowing this information, can you try and work out for me what this equation would factorise out to if I write the form out for you? So yeah, correct, it would be x plus 7, x minus 7. Great, so if you've got any questions, please let me know. That's all we've got time for today, so thank you so much.